Welcome back, friends! Today we are describing linear patterns algebraically. What does that mean? It means we're going to be taking a look at number patterns and we're going to express it algebraically, which means it's going to be a math sentence. And if you don't know what it is, stick around and find out. All around the world, you see patterns. There's patterns everywhere. You look around where you are right now, look outside your window, look anywhere. You see it on TV, you see it in your room, you see it all the time. In math, it's the same way. You will be able to see patterns in numbers, just like these. Can you spot those patterns? Yeah, there you go. For this lesson, we want to take those number patterns that we just saw, or any number pattern, put them in a table of values, and then be able to express them algebraically. So we're taking those number patterns and expressing them through algebra. All right, to explain this concept a little bit further, we're going to use the example of hockey. Anyone ever been to a hockey game? You should check it out. They're awesome. Anyways, before the game actually starts, on the bench, there's a pile of pucks for everyone to use to warm up. And so all the players who need to warm up, they would just take all these pucks and they would just put them on the ice, and that's how they use them. All right, so here's the question that we're going to try and answer. Write the algebraic expression for the pattern if the number of pucks increase by 2 each time. So yes, we're going to use hockey pucks, and the algebraic expression is what we're going to try and find out for the pattern of increasing hockey pucks, which increase by 2 hockey pucks each time. Let's get to this. Let's make a table of values right here, and let's start inputting our numbers. On the first night of practice, they had 3 pucks to warm up with. I don't know how hockey works. I know 3, just play along, okay? And then on the next night, they added 2 more pucks to the play. On the third night, you guessed it, they're adding 2 more. So 5 plus 2 is 7. And on the fourth night, you guessed it, is 9. As you can see, as the nights progress, it's adding by 2. I find that it always helps when we draw diagrams out to help out with our patterning. So on the first night, we had 3 pucks. And then on the second night, as you can see from our table of values, we had 2 more. On the third night, we had our original 3, and then the other 2, and then we added 2 more. And then on the fourth night, we had that much, and then we added 2 more. Let's take a look at what we're asked to do. We need to find an algebraic expression for this pattern that we see right here. This pattern continues to increase by 2 each time. Let's just label it correctly so that we know each time how much it's increasing by, which as we know is 2. So we're now going to label the days on this side as the expression n. Now, I don't know why they use the letter n. Maybe it's because it's such an awesome letter. I have no idea why they use n. Come on now. Well, n just universally will be known as term. All right, or the amount of time or days or passage of time that it's going to be in. So as we see over here, the first term, which is the first day, there's 3 pucks. The second day or second term would be here. Third would be here, and fourth would be here. So n will represent the day, or what we will say from now on, the term. So the nth term is here. Second term is there, which represents by the letter n. As we look at our diagram, can we figure out things that are fixed or variable? Fixed means it's always going to be there every single term. Variable is the things that we add. Here is one idea I'd like to show you, and tell me if you start seeing the pattern. Here is a fixed number here, and that is 1. Now, if you notice, if that's the fixed expression right here, and then you have 2, and then the second term you have 4, the third term you have 6, and the fourth term you have 8. How are these related? In the first term we have 2, the second term we have 4. Do you see the pattern now? The third term is 6, and the fourth term is 8. What kind of pattern do you start seeing there? Now it's time to start writing this out algebraically. It's clear that we've got one fixed number for every single term. And so let's start with that one fixed number. It's 1. You see a pattern with the remaining hockey pucks or circles? I noticed this, that the number of circles here is the term times 2. Do you notice that? So we're adding the term times 2, or 2n, which is the same thing as 2 times n. So I'll put the brackets here for times. And we can even write this out even further. We can say that 1 plus 2 times, and n for the first term is 2 times 1, is actually 1 plus 2, which is equal to 3. And if you count it up, that's 3. Now, will it also work over here? 1 plus 2 times n for the second term. Let's see. 1 plus 2. And what's n for the second term? Can you take a look at our table of values? For the second term, n is equal to 2. So let's plug in this 2 into the n right here. And if we plug it into n, we have 1. Oops, sorry. Let's rewind that. We've got 1 times, that's 2. 1 plus 2 times 2 is 4. And 1 plus 4 is 5. Can you press pause now and try and figure out the rest of the terms for term number 3 and term number 4? Try and practice that. And press play when you can. Okay, is this what you found out as well? That's it. Hopefully you got that. Here is another strategy by just using the table of values. Yes, we could use this expression right here, 1 plus 2 times n. We can definitely use this expression. However, this was derived or taken from the ability to take a look at the diagram. If we were to look at the table of values, we can even think algebraically by looking at the addition and multiplication of certain things. So we know that 2 is a constant here. Let's take a look at this. If the answer is 3, let's find out what times n would equal 3 with some addition. So let's try this. 1 times 2. So n times 2 plus what? What is n times 2 here? N times 2, 1 times 2 is 2, plus 1 is 3. Does this work? So let's go 2 times n. And let's see if the first one works. 2 times 1 is 2, plus 1. Can we try that for all of them? Let's try. 2 times 2, 2 times n, which is 2, plus 1 should equal 5. Let's try this. 3 times 2 is 6, plus 1 is 7. We now have another algebraic expression to express the hockey pucks being added 2 each time when we start with 3. All right. Now, I want you to find out what is the number if the term is, let's say 100. How many hockey pucks would there be on the 100th night? Can you figure it out? Press pause now to try and figure it out. We're not going to draw everything out, but we'll take both 2n plus 1 and our old 1 plus 2n. And we had brackets, but we don't need to put brackets here. It's just to show you that it's multiplication. Let's try it with the 100th term. 1 plus 2 times 100, which is also 1 plus 200, which should equal, there will be 201 pucks. Can we try it over here? Let's try it. 2 times n, which is 100, is 200 plus 1 is 201. And we just solved this pattern using algebraic expression. Before we go, let me give you one more example to help you understand it a little bit more. Let's start off with this question. Mr. Nicanor had one book in his library already, and he added 300 more graphic novels to his library on the first day. So he had 301 on the first day. Every day, he continued to add one more book. Can you tell me how many books did he have in his library on the 25th day of school? Press pause right now, and every time you unpress it, I'm going to give you a few hints. I'll give you 2 in total. So when you unpress, I'll give you one hint, and then do it again, and I'll give you another hint. Okay? Let's see if you get this. Press pause now. Okay, here's the first hint. Make a table of values. It looks like this. Can you keep going and complete this table? Press pause now and do that, and I'll give you another hint the next time you unpress. Were you able to finish it? It should look like this. Okay, here's my next hint. You need to try and find out what the algebraic expression is for this pattern. Let's find the pattern. Do you see what the pattern is? From one term to the next, you're adding 1. So what do we see that the pattern is? How is this plus 1 related to this and also this? So 301 is the first term, 302 is the second term, 303 is the third term. It seems like we're just adding the term to 300. Could that be our actual algebraic expression? So we can go 300 plus n. Or we can do it the opposite way as well. Are you now able to find out what the 25th term is? Let's do it together if you haven't figured it out already. If we're looking for the 25th term, and we know that it is n plus 300, if n is 25, then it's 25 plus 300. Your answer should be 325. Is that what you got? Celebrate! This is a big win! This concept is rather difficult and you need lots of practice. So if you were confused by this at any point, I highly suggest rewatching the algebraic expression parts of the video and slowing it down and just redoing all the questions along with me. Slow it down to every part that you didn't understand. It does take a lot of practice to get used to it, so ask me for some extra questions. I'm more than happy to provide you with some, or make some up yourself, and you'll be surprised with growing patterns that you'll be able to find an algebraic expression every single time. All right, happy mathing. I will talk to you soon. Bye now.